So now we're going to look and try to determine if a given function is even, odd, or neither. And we're going to look at two methods to do that. One is graphically, the other is algebraically. So remember, for an even function, the graph will have symmetry with respect to the y-axis. Algebraically, that will mean when you change the input from x to negative x, you do not change the output. Okay. And then for odd, this will have symmetry with respect to the origin. So it's a rotation of 180 degrees, which means, again, when you switch the input, you get the opposite of the original output. Okay, so we'll look at the graphs and then look at it algebraically. Okay, so the first one, we have f of x equal to x squared minus 7. The graph is here. It's a nice parabola. We can see that it is symmetrical with respect to the y-axis. So from the graph, we would say this is an even function. How do you show this algebraically? Well, again, what we are most interested in is what happens to f of negative x. What's the output look like? Does it look like the original function or its opposite? Again, keep in mind it could also be neither. Okay? So when you're trying to decide algebraically if a function is even or odd, we first find f of negative x. Okay, now again, just a reminder, when you have this f of x equal to x squared minus 7 function, you just want to think of it as it takes any input, and this function will square it and subtract 7. So whatever goes in gets squared and subtracts 7. So in this case, I plug in negative x, I square it and subtract 7. Okay. So this obviously then will simplify to x squared minus 7. Okay. And then again, what do I want to check? Is this equal to the original, the opposite of the original, or neither? Okay, well, clearly we can see the original, x squared minus 7, it's the same. So since f of negative x equals f of x, the function is even. In the next one, we have x cubed minus x squared. So again, the graph is here. Looking at the graph, it's clearly not symmetric with respect to the y-axis. So if you fold it across the y-axis, the two sides do not match up. As far as symmetry with respect to the origin, again, that's a rotation of 180 degrees, which isn't always easy to see. Okay, but keep in mind it would move everything in the first quadrant to the third quadrant, which maybe looks possible. Okay, but it also would move this little piece here from the fourth quadrant to the second quadrant, where clearly there is no match for it. Okay, so there's no symmetry. So I would think that this function is going to turn out to be neither even nor odd. Okay, algebraically, again, we calculate f of negative x. This function takes any input, cubes it, and then subtracts its square. So we cube the input and subtract its square. Okay, clean this up. Again, negative cubed would still be negative. The negative squared would be positive. Okay, so this is our f of negative x. Okay, so again, we have to compare it to the original. Well, that's not the same, so that's not even. We also compare it to the opposite of the original, so the opposite of x cubed minus x squared. Distributing that negative, that's negative x cubed plus x squared. Again, not the same as this one. So it's not equal to the f of x. It's not equal to negative f of x. So again, this function is neither even nor odd. Okay. And just a couple more. So we have h of x equal to x cubed plus 3x. So we have the graph here. Again, it's certainly not symmetric with respect to the y-axis, folding it across the y-axis. But a rotation, it certainly would seem that this piece maybe rotates around to here and this one up to here. So graphically, if I had to look at it and guess, I would say it is an odd function. Okay, that's why it's always nice to check it algebraically. So again, we're trying to calculate f of negative x. Okay, this function cubes the input and then adds 3 times it. So we cube the input and then add 3 times the input. Okay, again, cleaning this up. Negative cubed the negative being cubed is still negative. We have x cubed, and then this would just be minus 3x. Okay. Again, we compare it to the original. It's clearly not equal to the original, so it's not even. And then we compare it to the opposite of x cubed plus 3x. So distributing this minus sign, you get negative x cubed minus 3x. And we can see these two are in fact equal. So since f of negative x equals negative f of x, the function is that. Okay. And then one more, we have f of x equal to x squared plus 3 all over x. Graphically, again, it looks like there is some symmetry with respect to the origin, so my guess will be odd. Algebraically, we calculate f of negative x. Again, we square the input plus 3 all over the input. Square the input plus 3 all over the input. Okay, so we clean this up a little bit. So obviously this would just be x squared plus 3 on top and then negative x on bottom. Okay, and again, keep in mind when you can put that negative in front of the whole fraction. So again, f of x, remember, start out as x squared plus 3 over x. Clearly not the same. But the opposite of f of x is negative x squared plus 3 over x. Those are equal. So again, that will be an odd function.